Hi guys, in this video, I'm going to cover the AP Calculus AB and question number 3 of the FRQ. So take a look at this question, and we have the graph, and this graph is f prime, it's not the f. And it's a differentiable function with the f4 equals 3. And the interval is given as between the 0 and 7. Now, the first question, we want to find the f0 and f5. So as you can see, from the 0 to 4, we have a semicircle, right? So that being said, in order to find the f of 0, we have to use the f prime. As you know, from the 0 to 4, f prime of x dx, then that's the area of the semicircle. And then the circle area is a pi r squared. So in this case, pi r squared, and the r is a 2, right? So here, the radius equals 2. So that is a pi 2 squared, but this is a below the x-axis, so we have a negative sign. But not only that, because this is a semicircle, the area has to be half of it. So I need to divide it by half. So it becomes a negative 2 pi. Then on the other hand, the left-hand side, I can write down this way. So the left-hand side is a f of 4 minus f of 0, okay? Then you can find the answer. So what we want to know is that this unknown f of 0, but f of 4 is given as a 3. So that being said, 3 minus f of 0 is a negative 2 pi. So that's why the f of 0 is 3 plus 2 pi. That's the answer. So the common mistake is students, they miss this negative sign. Well, like I told you before, this is a below the x-axis. Even though the area is a 2 pi, we need to put the negative sign. Then you can find the answer. F of 0 is a 3 plus 2 pi. Now, let's find the f of 5. So like the same way, in order to find the f of 5, we need to use the area. So let me start from the 4 to 5 f prime over x dx. So why did I start from the 4 to 5? Well, because we know the f of 4. So that's why I'm trying to use that information. Then likewise, this one is a triangle, and the slope equals the 45. And as you can see, when x increases by 2, y is increased 2. So this is a 45-degree line. Then you can easily find this shaded area. That is just 1/2, right? So the width is a 1, and the height is 1, and the triangle's area is a 1/2. So that's why the right-hand side, you put the area is a 1/2, right? Then same as before, the left-hand side is a f of 5 minus f of 4. That is a 1/2. And then f of 4, we know that that's a 3. So f of 5 minus 3 equals a 1/2. That's why f of 5 is a 3 plus 1/2. 3 plus 1/2. That is 7/2, or you can say that 3.5. Okay. Take a look at question number B. As you can see, we want to find all points of the inflection. So what's the definition of the inflection? Well, when the f double prime, so second derivative of the f is changed, the sign of the f double prime for the second derivative is changed. That is the inflection point. So now just ignore this f prime. In order to find the second derivative, you need to capture the tangent slope of any points, right? So take a look. So for example, here, the slope is a negative, right? And here, slope is a positive. When is the slope is changed from the negative to the positive here? Before the x equals 2, you see that the slope is a negative. After the x equals 2, the slope becomes positive. So that's the inflection point. So I found the first inflection point, that is x equals negative 2. Well, there's one more here. When x equals 6, you see that this is it's not differentiable at x equals 6, but at least I know that before x equals 6, the slope is a positive, and after x equals 6, slope becomes a negative, right? So the slope is changed from the positive to the negative. So that's why we found the two inflection points. Sorry, this is x equals 2. And then the other one is x equals 6. So one more time, this is a graph of the f prime. In order to find the inflection point, we need to have the f second derivative, right? But then the f second derivative of the f, we know that the slope is changed when x equals 2 and x equals 6. So that's why we found the x equals 2 and x equals 6. These are the inflection points. Now let's go to the question number C. So let G be the function defined by this one. So this is a given. G of X is f of X minus X. And then the question asks us on what intervals, if any, is G decreasing for between the 0 and 7. So in order to find whether the G is decreasing or increasing, we need to find the derivative. So you can easily take a derivative of this G of X. So when you take a derivative with respect to X, then the left-hand side is G prime X and the right-hand side is f prime of X minus 1, right? So what does that mean? Well, we have the f prime graph, right? And the f prime of the X minus 1 is like this. So let me change the color of this one and to the purple. And if I draw the G prime of X, then it looks like this one. So here, this is a G prime of X. How do I know? I just need to shift this f of X below by 1. Then that's a G prime of X, right? Then we can find the answer. G is decreasing when? Well, we just need to capture when G prime is a negative. Well, I just found that here, between the 0 and 5, G prime of X is below the x-axis. So that being said, when X is between the 0 and 5, that means a G prime X is a negative. So we just found that the range that is from the 0 to the 5. Okay. Now the last question. For the function G defined in part C, find the absolute minimum. So how can you find the absolute minimum? Well, it's very straightforward. In order to find the absolute minimum, you need to check that when this G prime of X, the sign is changed. Well, first, as we solved the previous question, G prime of X is below 0 or less than 0 for X is between the 0 and 5. And also G prime of X is positive. When is it? For X is between the 5 and 7. So that being said, when X equals to 5, that's the minimum. Well, let me give you the big picture of this question. So let's say that this is h of X. When is the minimum? Here. How can you find it? Well, slope is a negative before this point, and it becomes a positive, right? So it's the same thing. Before the X equals 5, the slope is a negative. And after 5, the slope becomes a positive. That's why I can get to know the absolute minimum is a point when X equals 5. That's it.